13.
13. Okay, so in the previous lesson, when we evaluated these radicals, we didn't have anything left over. Like it went in evenly, right? The 6th root of x to the 18th is x cubed. Well, what if that wasn't x to the 18th? What if it was the 19th? Can we still simplify that? Bless you.
No,
Yeah. We can. Okay, for example, think back to, let's say it's the square root of 20. We can simplify this, right? So how can we break that down? 5 and 4? So I can actually, I could either do the factor tree, or I can rewrite this as square root of 4 times square root of 5. This is the product property of radicals, where you can either multiply them together to make it the bigger number, or you can break it down into something smaller. And so we get 2 root 5. Good? So that is an example of this property. Good? Of course, you've done square roots before. Now we're going to do 4th root, cube root, 5th root, and so on. It's all good. Okay, 4th root of 32. Now, I have 2 ways I can do this. I can either do a factor tree, or I can think of, is there a 4th root of something that goes into 32?
Oh, wait, no. Oh.
You said 16?
8 and 4.
8 and 4?
Yeah.
But if I have the 4th
16 and 2.
16 and 2.
Wait, so you have to add the 4.
Wait,
and then
does
4.
it? Okay. Now, I could have done a whole factor tree, and I would have, 32 would have ended up being 2 times 2 times 2 times 2, 5 times. So I'll show you 2 different methods. But if you know, if you know that the 16, what's the 4th root of 16?
4.
2, because 2 to the 4th power. So this would be 2 with a 4th root of 2 left over. Whoa. Because I can't simplify this any further, but this ended up giving me a whole number.
Would you get the same answer if you did 8 and 4?
Watch what happens if I do a factor tree. Same thing. So let's see, 32 is 8 times 4, 4 times 2, 2 times 2. So I have 4 2s with 1 left over. So remember when we had the square root, what were we always looking for? We're looking for pairs, 2 of the same. But if it's a 4th root, I'm looking for 4 of the same thing. If it were a cube root, I would look for 3 of the same thing. So I have 4 2s, but I had 1 left over. So that means I have a 4th root of 2 remaining. Okay. This first one, if you're good with the mental math, like if you can think of, oh, cube root of 8, 8 goes into 32 or something like that, that's great. Otherwise, you can always do the factor tree. You'll get the same answer. Okay? Let's look at the next one. Now next one has a variable. Okay, 3 doesn't go into 7 evenly, but 3 goes into 6 evenly.
Oh, you're going to have a remainder of 1.
I'm going to have a remainder of 1. So I'm going to show you 2 ways to do these as well. So I can do d to the 6 and a d to the 1st. I technically don't need to put that one. Right? We agree 6 plus 1 gives us the 7 underneath. Well, what's this one going to end up being? 2. So I have cube root, d to the 2nd times the cube root of d to the 1st.
You don't need to put
What about
multiplication?
it's implied that it's multiplication. If you want to put a multiplication in between, you're welcome to.
What about the square root for because I get that 3 divided by, or.
Another way to do this is just do a quick long division if you wanted. 3 goes into 7 2 times. Right? So I got d squared. Keep going with the long division. 3 times 2 is 6. 1 is my remainder. So I ended up with a d to the first left over. Okay. What do you think? 2 different ways to do it. I don't care which way you choose. I know Reed would not care. Which one do you like better? You like the first one? I do too. Okay, now keep in mind there is an invisible 2 there. It's a square root.
So you have to factor out 12, so 6 and 2.
Okay, so 12 or 4 and 3. So maybe what I would do, if I want to use the first method, bear with me for a minute, I'm going to make this a 4c to the 6 d squared with a 3 d to the first.
Oh.
Okay, why did I do that? Why did I split it up?
6 and 2.
So if I'm using that first method, I'm thinking, what perfect square goes into 12? 4, with a 3 left over. The c square, or c to the 6th power is perfect, because that's 2 is going to go into that evenly. And the d to the 3rd power, I'm going to divide up into d squared and d to the 1st. Now, what's nice is I don't have to do anything with that second part. What about the first part, though?
So then it's going to be
2 c to the 3rd,
D,
and then
3D.
3d. Again, could you have done the factor tree with the 12? Yes. Could you have divided 2 into 6 goes 3 times 2 goes into 3, 1 with 1 left over. Good. Okay. Question. Okay. All right, let's do the next one.
Wait, can't you do 3? So
Is 27 a perfect cube?
yeah.
Yes. What would I make y to the 4th? I'd split it up into 3 and 1, and z to the 7th, I would 6 and 1. Good, so let me just rewrite it.
But can't you do 9, right? 9 times?
Well, hold on, 27 is 3 times 3 times 3. So I'm actually going to leave, oops, I meant that to be a 3.
Whoa. What did you just do?
I'm dividing it. Okay, 27, sorry, that's a cube.
Yeah, but aren't you supposed to, you see how like you did there 4 and 3 because it equaled 12?
Why wouldn't you do
Okay, because
3?
this was a square root.
Oh.
This is a cube root. If that was a square root, you're right. I would do 9 and 3. But since it's a cube root, I'm going to keep that 27 with the first radical. You kind of see, you're trying to just basically look at what's going to go in evenly, what are we left over with, and then simplify the first one. What's the first one going to end up giving us? So cube root of 27, 3, good, with a cube root of yz left over. I know these can be a bit tedious, but if you just follow those steps, it'll be fine.
Are we gonna have like harder, like bigger, harder numbers where we'd have to do the factor tree, or like? Because I don't understand
bigger numbers. I posted, keep in mind, on my JAG, our pages are now linked. And I posted all the answers are on my JAG, right? So you can check, it doesn't have the work, but you can at least check your answers that way. And we wouldn't expect you to do that without a calculator if they were like bigger numbers. Okay, quotient property. When do we need this? Well, let's say you had, if I had square root of 49 over 81. Okay, just like with the multiplication, I could split it up into square root of the top, square root of the bottom. And what's that going to give us? 7 over 9. So that's an example of that. Now, what happens when we have a square root left over in the denominator? What if that didn't go evenly? What do we call that? Rationalize the denominator. So we have to multiply. I know, it's been a while since we've done some of this. Some of you, I had in Algebra 1. Okay. All right, so let's look at rationalizing the denominator. If I have something like 1 over square root of b, what do I want to multiply by? Square root of b over square root of b. So here's my example. 5 over the square root of x. So what do I want to multiply the top and the bottom by? Square root of x over square root of x. So I get 5 root x over x. Well, it would be square root of x squared, but what happens then? You just get x, right? The square root and the square cancel each other. It doesn't look very simplified, but we count that as simplified.
What if there's a number on the bottom?
That's okay. We just leave the number.
No, like.
You mean like a 2 in front?
No, like instead of x, it's like 2.
Like a square root of 2?
over square root of 2.
Yeah, then we will multiply by square root of 2 over square root of 2.
So it would be just square root of 10 over.
It would be 5 root 2 over 2. Like if we had 5 over square root of 2, we would have 5 root 2 over 2. Remember, whole numbers, we don't combine those with the radicals. If this was square root of 5, then we would multiply square root of 5 times square root of 2 to make that square root of 10, but otherwise we keep them separate. Yeah,
So for this 7 over 9, would that one, like, would you square root each and then do the multiplication?
if I had something left over, you mean? Like another radical in the
Because
bottom?
can't you simplify 9?
No, I'd leave it. This I would leave because we're just doing the square root one time.
Okay.
Yeah. Okay, now this one gets a little more confusing. When we don't just have square roots, if we have a cube root, or a fourth root, or in this case, a fifth root, what we want to do is we want to figure out how much do we have left over. I know that notation looks a little scary, so I'll just show you what that would look like in our example here. How can I rewrite 4? What number is that to what power?
2.
Okay, so I'm going to rewrite that as 2 squared. Now, I need to multiply by the fifth root of something over the fifth root of something. This is 2 squared. How many more 2 to what power would cancel that radical? Think about it. If I have 2 and I want it to equal the index 5, how many more would I need? I need 3 more.
Wait, so it's 3 root 2 to the second. That's just 5 root 4 rewritten, right?
Yeah, that's just rewritten. Okay, so the first thing I did was I rewrote so we have an exponent. Why do I want to do 2 squared and 2 cubed? What happens when
you just add?
Yeah, we want to make these exponents, right, equal the fifth root, because this will be 2 to the 5th power, right? So,
I don't
Yeah,
know
sure.
where you got the 3, like 2, or
you'll see in my next step. Watch what happens in the next step. I have 2 times the 5th root of 8 over the 5th root of 2 to the 5th. Okay, why was that important? What am I trying to get rid of on the bottom? The radical. So if I have the 5th root of something to the 5th power, what do I end up with just in the denominator?
2.
Just 2. Oh, I'm sorry, nobody caught that. I put a 2 in front here. This is supposed to be a 3. Okay.
I caught it.
You caught it, you didn't tell me.
I figured you knew what you were doing.
more than I
It's
did.
because 2 times 2 times 2 is 8.
Yeah, 2 to the 3rd power is 8. So there's nothing I could do with the numerator, but there's a reason I wanted to multiply by 2 to the 3rd, because I want to make these match so they cancel each other out. So I get 3 5th root of 8 all over 2. A little bit messy, I know. Yeah, fine.
Well, I got 3 to the 5th root of 4 to the 4th. Over 4.
Okay,
How'd you get
So-
2?
that's technically the same answer, but not simplified all the way. So you would have to go through further because 4 can always be broken down.
Wait,
Yes, I'm waiting.
but in the top I got 4√4 in the radical, but that.
So if you did 4 to the 4th power here and here, you would have to go a step further. Let's do some more examples and you'll get,
Miss Casey?
Yeah.
I'm a little confused how you got 5 to 2 to the 5th.
2 to the,
I mean, no, wait, I understand that.
I don't get
How'd you get 2 from 5 to the 2 to the 5th?
oh, so the 5th, so these, this and this basically cancel each other out. Right?
Did the cube or like the 2
Like-
to
Like if I had the square root of 3 squared, wouldn't that just be 3?
Yeah.
If I had the third root of 5 to the 3rd, that would just be 5.
Yeah.
So if I have 5th root of 2 to the 5th, I just get 2. I no longer have a radical in the denominator. That was my goal there.
how did you get 2 to the 3rd power?
So what I'm trying to think about is what, if I have 2 to the 2nd power and I have a 5th root, how many more powers of 2 do I need to cancel it? 3. What if I had 2 to the
So you
first
can
power?
add any exponent?
You can add any exponent. So if I had 2 to the first power, I would need 4 more. Right?
Which is, it's not addition.
The exponents are addition.
Oh, okay, so that's how you got
2 and 3 add up to 5.
I see.
Okay, let's try the next one. Okay, first thing I want to do, I'm going to rewrite this as square root of y to the 8th over, again, I want to think of 9 as what power? How can I rewrite 3 to the 3 to the 3 to the 3rd or 2nd? Now, I didn't really need this step because if you notice, it's just square root of 9. I just want you to get in the habit of it because what if it was cube root of 4th root of 9? So what's going to end up happening, let's simplify that first and then see what we have to multiply.
Wait, oh.
This one, what ends up being in the numerator? Remember, there's a little 2 here. What's
Y to the 4th.
y to the 4th
And then
over 3 with a square root of x left over, right? I wasn't able to pull that x out, but I was able to do the 3. Now, I don't want to leave square root of x in the bottom, so what are we going to multiply by? Good. Do square root of x over square root of x.
Wait, but what about the 3?
The 3 just stays there. We don't need to worry about that because there's no radical over the 3. Okay, what do we get for?
Y.
So we get y to the 4th square root of x over just 3x. I know, this is, out of all the lessons in this chapter, I think this is the most difficult one. Which means the ones after this will be easier.
So
Okay.
the square roots cancel out.
Yeah, the square roots cancel out. Okay. I'm going to rewrite this. Notice this is a cube root of 2 over cube root of 3 squared. And that's just an x. I'm going to put first power for right now. Okay. What
Why did you do 2 and 1?
because I rewrote 9 as 3 squared. Remember how I said, like, if you have like numbers, rewrite them like as powers. So what I'm going to do, I need to figure out what am I going to multiply by. Okay, so notice if it's cube root, I need cube root. How many more do I need to get them out of the radical? I have 2 3s, but I need 1 more. So I need a 3 to the first. And how many more x's do I need?
1, 2,
I have 1,
2.
so I need 2 more.
Or
Yeah, x squared. So whatever I multiply on the bottom, gotta multiply on the top. Good.
you have to have 3 to the first. Can you just write?
You could just write 3. the only reason I wrote it is so you could clearly see 2 and 1 combined to 3, 1 and 2. Okay, what do we got then? Well, how about the top part? So we get cube root. Good. 6x squared. Well, because so we're going to combine the 2 and the 3. And then there was just an x squared. Okay, what about on the bottom? Can we just write
27.
well, 3, what ends up happening here? What am I going to end up with on the bottom? Oh, everything's going to cancel, and I'm just going to get 3x on the bottom, right? Do you want me to write out that step? Here, I'll write it out.
Is it 3 root 3x?
Because it's going to be 3 cubed x cubed. So that's how I get 3x.
Oh my god. Wait, what's that?
This last step is optional, okay? I would say this last step is optional. If you recognize what you're going to end up with, you could just put 3x on the bottom. Because our goal is to always get everything to cancel, the radicals all to cancel on the bottom. Okay.
You don't do this, but like with solving when it's actually.
Now, this is, I don't want to say, like, it's, these are necessary but annoying.
Why is this necessary? We're never gonna
Because
use it.
we are going to have further applications, also in pre-calculus, you do more with the exponents. But
What about the radical?
yeah, the radicals too. I know. It's fine.
Why can we all we need to do is plus minus multiplication and division.
Unless you're gonna be a scientist or.
I disagree.
mathematician.
Okay.
Well, if you go to a store, you're not gonna use this.
You never know.
What? I don't know what store you're
Figure
going
out how
to.
much.
Okay.
But I'm going to Trader Joe's.
Okay, Let's take a look. Simplifying radical expressions. Okay, remember how before we broke them apart? Could we also combine them? Yeah. So let's see here. First of all, there's a 5. I'm just going to leave that 5 out here. Okay. What's 1,000 times 10? Or sorry, it's what? Gave you the answer. What's 100 times 10? 1,000. I said it backwards. Okay. And a squared times a to the first. Good.
And then it would be 5 root 1,000.
Okay, so what's the cube root of 1,000? 10 times 10 times 10 is 1,000. Right? How many zeros do we have?
1, 2, 3.
That means it's 10 to the third. So I get 10 a to the first power.
Okay.
Right? Cube root is going to cancel.
Oh,
Can I multiply? Yeah, I can just multiply the 5 and the 10. 50.
How did you get 10a if 3 and 3 cancel? Yeah, would it just be 10?
No, you still have the a
The
there.
exponent cancels off the
3 divided by 3.
The cube root of 1,000 is 10. The cube root of a to the third is a.
And then do you add the exponents of 2 plus 1 is 3?
Oh, that's good.
Okay, so let's do the next one. So first of all, I see a 6 and a 4. Those are outside, so those are just going to get multiplied together. And then this one's actually easier. It's a square root. Okay. Numbers always get multiplied. The exponents get added. So 8 times 2 under the radical gives us 16. C to the fourth, good. D to the eighth. And luckily, I believe that all cancels for us. So square root of 16.
Is there still a 2?
Yeah, there's still, whenever there's no radical symbol, we just assume that's a square root. So now we're going to get square root of 16, 4, C squared, D 4.
When shop is done?
Yeah, last weekend. Last
You
weekend.
asked me this in the car this morning too. Oh. And then do we multiply?
Yeah, can we multiply those coefficients? Yes, 24 times 4? 96.
76. 96.
get d to the 4, right? 'Cause
Two goes into d to the 8 4 times.
okay.
It is?
Okay, this is actually review from Algebra 1. I know, can we remember all the way back then? 4 root 8 plus 3 root 50. Okay, how can we simplify square root of 8? There's a lot of different stuff in this lesson here.
4 and 2.
2 root 2? Okay, square root of 50. What perfect square goes into 50? 25 times 2. So square root of 25 times 5 root 2. If you need to show the work on the side for those radicals, great. If you're able to jump right to that answer, fine as well. What do we want to do now? Multiply the coefficients? So it's going to be 8 root 2 plus. Okay, good. Remember, we can only multiply the numbers that are outside the radical and the ones that are inside the radical, but we can't combine them. Can we add these? Yeah, they're like terms. They both have a square root of 2. So it's 8 and 15. 23 root 2. Okay, next one, same thing, just different numbers. Okay, 45. What perfect square goes into 45? 9. 9 times? 5. So 3 root 5. Good. So I'm going to have 3 with a 3 root 5. Good. Okay, square root of 80 might be more difficult. What's the largest perfect square that goes in? But a perfect square.
64.
16. It's okay, I'll just tell you. 16.
Wait, no.
It's 16 times 5.
So
4 root 5. Again, if you're not sure, could you go over on the side and do a little factor tree? You're going to get the same answer.
10.
No, not.
For what about
4 and 5.
4 and 5? So square root of 4 is 2 with a root 5.
Wow.
Okay, so fortunately, I mean, it's good when we get all the same radical because then you know you'll be able to just combine them all at the end.
9 root 5.
I feel like I got an eyelash in my eye. Let's see here. And combine all the coefficients.
Wait, I need more.
Negative 11 plus 8, so negative 3 root. Whew. Okay. I promise it does get easier.
Oh,
after
yeah,
this
yeah,
lesson.
yeah. I see.
There's still more.
Oh, there's still more.
There's still more. Hang in there.
I can't.
We got this. Do we need a...
I'm going home after this class.
Our brains are fried after this? Okay.
Yeah.
All right, next one. We got 2 binomials. Means FOIL. Okay.
Wow.
In middle school, I was taught to not, like, I was never taught how to do that because, I don't know, we were, like, taught another way, and, like, now we use it all the time. I don't know how, because I was,
It's just
First, outer, and
last.
last.
I would use it, I was just taught.
Yeah.
Okay, so listen. If you learn distributive property, which is the other way we would say FOIL, it's the same thing. You should get the same answer. But if I say first, I'm referring to multiply. Okay, so let's.
The first and last, and then the second and third, and then add them.
I mean, you're just adding all of them, so it
Yeah.
does not matter.
It doesn't matter.
Yeah.
So if I do 2 root 3 times 3, that'll be
6 root 3.
6 root 3. Okay, now I want to do.
2 root 3. That's 9 root 5.
Wait. Minus what?
Minus 2 root 3.
But isn't it root 3 times root 3?
So minus 2 root 9.
Root 9, which
So
is.
6. It's 6.
It's 6.
Oh, I see what you did.
Yeah, you see that?
Oh, you add.
Because it's 2 times root 3 times root 3. Root 3 is 3, so 2 times 3.
got it. So,
If you need, right now.
how you got 6 root 3 is because you did 2 times 6. 2 times 3.
Yeah, because root 3 times root 3 would just give us 3.
No, for the first one.
Oh, I see.
Oh,
now,
yeah,
I
here
see.
times here, yeah. The 2 and the 3. Okay, now we'll do the inside, so that will be, so that's going to be a plus 9 root 5.
right? Because I can't combine anything else.
For the,
How'd you get 6?
cause 3 times 2, or I mean, no, 2 root 3 times
2 root
negative.
3 times negative root 3, so root 3 and root 3 just become 3.
Yeah.
2 times 3 just gives
Yeah.
us 6. Okay, how about the last? So it's gonna be minus
3 root 15. Now, can we combine?
no, thank goodness.
I don't know
Okay,
how we're done.
Just leave it like that.
We could just leave it like that. It's a messy looking answer, but there's no like terms. Nothing has the same number under the radicals, so we're just gonna leave that.
Okay.
What's the matter?
You do.
Because they're all different. This one has a radical 3, this one doesn't. That's a
Wait,
15.
so next one would it be 14 root 2?
Well, it would be 14 times 2 because
49
times 2.
49 times 2.
Root 49.
Yeah, 49 times 2.
Wait, why times 2?
Because
Root
you
2.
multiply root 2 by root 2, which gives you root 4, and then if you simplify that, you get 2, therefore it's 2, and then you multiply 49 by 2.
You got it. Okay, next one. So that's going to be plus 21 root 6. Right? Multiply the 7 and the 3.
Multiply the root 2 and, but look what happens on the inside.
The outsides. What happens when we multiply these? Minus 21 root 6. Oh. That's canceled. And how about the last?
Minus 9 root 9.
Minus 9 times root 9, which is 3.
Wait, why do you do times? It's not root?
They just cancel each other out.
They just cancel, right? Plus 21 root 6 minus. Okay, so this will be.
It would be 49 times 2 minus.
Okay, so this is 98 minus 27.
Wow, this is a long one.
I know.
71. Long lesson.
Oh, Reed's lucky she doesn't have.
She'll come back.
She is.
She'll have the easier lesson.
I'm glad that we're doing this with you.
Yeah.
Okay. And I'm doing a screencast, so.
If you miss something, we can come back to it. Okay, the last thing.
Something called a conjugate. You remember that?
No.
Okay, so basically a conjugate is the same thing that's in the denominator, but we switch the sign in the middle.
So we're going to multiply by square root of 6 plus 5 over square root of 6 plus 5.
What this does is in the denominator, we don't have to do FOIL. We just have to multiply the first and the last. Remember when you're multiplying like a plus b times a minus b? You just have to do a squared minus b squared.
Same thing here. So here's what we end up with. 8 root 6. Don't forget, I do want to distribute. So it's going to be 8 root 6 plus 40.
What's going to happen in the denominator?
Do they just cancel?
Okay.
Oh,
What's
the
root
6
6 times root
minus
6?
36.
36.
6 minus 25. So we just get, oops, my computer just turned off.
19.
Is that what we get?
Yes.
Oh,
Sorry, guys.
oh, wait, it's 8. So wait, the 8 root 6 plus 40
No, it's
stays?
plugged in. No, sometimes
It does?
when I do a screencast, it glitches. Okay, that's fine.
So yeah, what do we get in the denominator?
Negative 19.
Negative 19. And just leave it like that.
Wait, so it would be
That wasn't true.
8 root 6 plus 40 over 19.
Do we have homework on this tomorrow?
No,
we don't
we'll
have
have
class
tomorrow.
No, it's not till Thursday.
Wait, you don't have bonus tomorrow.
Oh, I hate when.
Yeah, I don't understand why we.
Okay.
Is it negative 19 or just?
It's negative 19 on the bottom.
Okay, looks like we only have time
We
for
can use
one or
the board.
two.
Yeah. Oh, never mind.
What would we multiply this one by? Oh. Oh, there we go.
6 minus root 3.
6 minus root 3. But at least we got to all the topics here.
Oh, wait,
Okay.
okay,
So in the
for
top.
A.
Yeah.
Is that the final answer?
No, say here.
Oh.
So 36 minus.
Also, I posted all the answers I put solutions to the whole notes packet online. So even though we're not going to be able to finish all these examples,
So it equals 36.
minus 6 root 3, minus 6 root 3,
So yeah, for the top three.
Why 6?
Okay, so we're doing FOIL on the top.
Whoa.
Here
Oh,
we go.
we're foiling.
We're foiling on the top, but the bottom we just have to do first and last. So 36 minus 6 root 3 minus 6 root 3 plus 3.
6 root. Wait, but why don't you have to
Plus,
FOIL
because it's
on the
plus
bottom?
root nine.
Because the outside and the inside will cancel. See, minus 6 root 3 plus 6 root 3.
Okay.
What the?
Okay, so we get 39 minus 12 root 3 over 33.
I don't know how you got that.
And
Wait, like I did
Can we do a
Okay,
partner
I'm
test?
actually
A
so.
partner test, huh?
Yes.
really not good.
Let's do a partner test.
Wait, but also a partner test, like what if the other person doesn't?
Yeah, then you're both out.
Yeah.
Okay, but we got to everything. These are just 2 more examples, but they're the same thing. I'll post the screencast. You can look at the solution.
Are you here to
Listen, 13 minus 4.
I'm here. Well, you don't have a reach tomorrow.
Can we?
But she'll be back tomorrow. But you're always welcome to come see me as well. Oh, okay, you can. Okay.
Thank you for
Okay, I know that was kind of a